Yes, is it visible to you? My screen is visible to you? Anyone reply me, Jashan?
మేడం స్క్రీన్ ఏం రావట్లేదు మేడం. ఇప్పుడు వచ్చింది. స్క్రీన్ వచ్చింది మేడం.
Okay. So this is first session. So I'll start my session. So this is actually the topic is engineering mechanics, and here I have taken in this format of our SVC PPD. Okay, so engineering mechanics class. Actually, the syllabus is the basic principles involved in engineering. So in a gate also, this is the basics for with the help of this you can attend the dynamics. So you won't get the direct questions, you'll get indirect questions. That means how to solve the forces and how you can work out this particular mechanics in various subjects, that is kinematics, dynamics, and fluid mechanics. So in that places, these concepts you will apply and you will do the problems. So especially the applications of mechanics, you will get the questions. So before going to the all the applications, you should read this engineering mechanics. So today I will cover all the basic principles involved in engineering mechanics. So in your GATE course also, the syllabus is totally the mechanics concepts, equilibrium conditions, and as well as friction related topics. So these are all the things they covered in engineering mechanics. Along with this, there are some more topics that rolling friction and forces involved in variety of or different bodies. So these mechanic principles, especially in trusses and frames, also you'll use it. So you can use in so many places these mechanics principles. So some very few questions only they will ask in basics. They will ask for trusses, fluid mechanics, kinematics, body, and as well as in dynamics, how the reciprocating parts are acting in a particular body, or rotating parts, how it is acting in a particular body, like that only they will ask. So these are all basic principles. Already you studied these things in your engineering mechanics subject. So now I am recollecting everything for your basic principles involved in this. So design of machine elements, transmission systems, everything comes, all the design subjects involved in this mechanics. So in this particular class, I wish to cover all the basic principles involved in engineering mechanics. So you just see that the outline of this particular classes: introduction to engineering mechanics and classification, force systems and types. So if you need the mechanics means, first you should know about the force systems and laws used in resolved forces, and Varignon's theorem, resultant determination and forces, system of couples and free body diagrams, friction and its laws, and types of friction, and equilibrium of force systems involved in frictional forces. So these are the major topics. So how much it is possible, I'll cover the next class in the next class. How much I can cover in this 1 hour, I'll cover it. Later, I'll continue in the next class. Okay. So how the forces are involved here? What is mechanics? Mechanics is totally dealt with a body forces which are resting, which are in rest condition or in moving condition. That is called mechanics. So what is meant by mechanics means the body is in rest condition means that is static, and moving condition means that is dynamics. So the mechanics is majorly classified into two categories, statics and dynamics. So before going to this, engineering mechanics is basically classified into two categories. So that means based on the object of the body, the molecules, based on the molecules of the body, it is classified into major way: fluid mechanics as well as solid mechanics. So the fluid mechanics, again, it is classified into two categories: solid mechanics and dynamics. And here solid mechanics, again, it is classified into two categories: mechanics of rigid bodies, mechanics of deformable bodies. So here the deformable bodies, this total structure deals with engineering mechanics. The solid mechanics is nothing but you will deal this total thing, solid mechanics. So engineering mechanics basically classified in two categories, but majorly they will identify this in the solid particles. So they'll ask that the solid related questions only they will ask. So how the forces are acting, how the reactive force is acting, like that. In fluid mechanics, it will come under gases as well as liquids. So in the fluid mechanics, the fluid means it indicates that gases and liquids, both the things comes under here. So now we will deal with solid mechanics alone. So in the solid mechanics alone, if you are taking here, you will get the two categories: mechanics of rigid bodies, mechanics of deformable bodies. These things already you studied, MOS, strength of materials, or simply mechanics of solids. You can say like this. So in this mechanics of rigid bodies, that is strong bodies, you have the two things: statics and dynamics. So this is rigid bodies are nothing. There's no deformation. There is a very negligible amount of deformation. So that's why it's called that rigid bodies. So the deformation is what we can say negotiable. This is called the rigid bodies. There is no change in body's structure, but it supports the total force acting on it. So that is the rigid bodies. So in the rigid bodies, statics and dynamics you have. So dynamics again divided into two categories: kinematics and dynamics. So dynamics you study alone, the kinematics you study alone, and here the whole thing fluid mechanics you studied alone, and here strength of materials, mechanics of solids. This one also you will read. Already you studied, I think so. So any disturbance, cracker sound is there, na? Are you getting
Yes,
any sound?
ma'am.
Yes.
Page
For
has
2
been
minutes.
stuck, ma'am.
Page, huh? This is
Yes, ma'am.
engineering mechanics divisions I have given.
Not, ma'am. First page itself it has stuck.
Oh, 1 second, ma. I have changed the page, but it is not coming. Again, 1 second, I will show you. Now is it visible? I'm not getting.
స్క్రీన్ విజిబుల్ లేదు మేడం.
అవునా? Now sir, visible అవుతుందా? Yes. So these are the main major specifications.
ఇప్పుడు వచ్చింది
You
మేడం.
just see the engineering. Okay, thank you. So you just see that the base of this, it is like a basement. It is like a root. It is not visible along. But the root is in the top. The total fruits and leaves are in the bottom. So if you are seeing like this, so the fluid mechanism is the area. So in this you will read actually gas dynamics also there. So fluid mechanics also there. And if you are coming solid, each and every
Ma'am, screen
word
presenting has
studied
been stopped, ma'am.
individually.
Ma'am, screen presenting has been stopped.
Now it is visible or not?
Visible.
Yes. Anyone?
Not visible.
Now,
ma'am.
yes. So this one, now, so I already said about this dynamics, mechanics, everything. So now we will move to the subject. And so here, what are all the fundamental laws? So these laws you should very clear with this. And these laws already you studied. Am I audible to you or not? You just anyone tell me.
Yes, ma'am, it's audible.
Audible, ma'am.
Yes, good. Because I could not able to make it. స్క్రీన్ మాత్రమే కనిపిస్తుంది కాబట్టి ఏమైనా ప్రాబ్లం అయితే కాల్ అన్నా చేయండి, ఓకేనా? సో దిస్ ఇస్ ఫండమెంటల్ లాస్, న్యూటన్స్ సెకండ్ అండ్ థర్డ్ లా. సో దిస్ ఇస్ వెరీ ఇంపార్టెంట్ లా, parallelogram law, polygon law, and transmissibility law. So in these laws, these Newton's first, second, and third law, you know very well. And in this mechanics, come with your force resolving. So forces resolving, this transmissibility law and Theorem plays a vital role in all the forces involved. So this is very important. First, second, and third law you know very well in which way you have to apply everything. But Lam's theorem, transmissibility law, and Varignon's theorem, you should know that how you have to apply in objects to resolve forces. Okay, so that things we will see now one by one. So first law, second law, third law. So first law is nothing but for every action or unless otherwise, if the object involves with some force, otherwise it does not move. So without any force, the body does not move to any movement or any displacement. It does not take any displacement. That is the first law output. The second law is whenever you are giving some force, the velocity also in the same direction. So that is your second law. Speaking, when you are applying some force on a body, when the force is moving in some particular direction, the same direction, the velocity, the speed will also move. The acceleration, speed, everything. So the multiples of your distances, you will get speed, F equal to ma. And the third one is for every action there is a equal and opposite reaction. So that is the third equation, third law. So these are the things you know very well. And now come for Lam's theorem. It's very important. If a body is in equilibrium under the action of three forces, so here you should know about the type of forces. So types of forces are nothing but concurrent force, coplanar force, if one by one linked it is collinear force, everything comes under this. And QR. My screen is moving now. Any problem in this presentation? Fine. So you just see that concurrent force. So here Lam's theorem is nothing but where it's involved. Here you read about the types of forces. So the types of forces are nothing but concurrent force, coplanar force, collinear force. We will see now. The Lam's theorem involved when three forces are in a single point. Laws used to resolve forces. Change avaleda. Lam's theorem chudita. Lam's theorem chubiledamma.
No, ma'am.
No. What happened? Okay, now it is visible.
Yes, ma'am.
Okay. If I'm going for a full screen, now it is visible. No, Lam's theorem. Yes, ma'am. I'll complete this. So now you just see that if three forces are in a single point, automatically you can resolve the forces. So where it is applicable, if you know the two forces value, you can find out the third force with the help of this Lam's theorem. So how can you find out here? So if P is one force, opposite these two forces in between angle is directly proportional. So that is your Lam's theorem. So P by sin alpha equal to Q by sin beta equal to R by sin gamma. So this is the thing you need to find out here. Okay, so now you just see that this triangle law is as usual based on, it is similar to your Lam's theorem, but you are taking that two forces acting in a single direction, the third force or the resultant force acts in the opposite direction. So that is your triangle law. So now if you are coming for here Bollinger Law, it does not give exact result. So that's why they won't use that much. And parallelogram law involves that if two forces are acting in a particular point, so the diagonal gives the resultant. So that is parallelogram law. Then transmissibility law involves that. It's very important. Transmissibility law is very important. The state of rest or uniform motion of the rigid body is unaltered if the force acting on the body is replaced by another force of the same magnitude. This is a simple example is if the lorry or if the vehicle, when you are pushing in the back or when you are pulling in the front, both are same. So that is the meaning for this transmissibility. So how it is very helpful. So if you are taking this particular body, here so many forces are acting. So, but if you are applying this transmissibility law, you can convert all these forces in a single point. So the same direction of particular one you can apply. Just see here, this force is replaced in this particular point. The same line of action. The same way here, if you are taking this particular truck, so this particular point, so one force is acting up, another force is acting down, one force is acting here, another force is acting up. Suppose if I am taking this particular tire, so this force is same direction, same line of action, I can transfer. And this force is same direction, downward direction, so I can transfer here. And this force is same direction, I can transfer up. So if you use like this. So this is the main important law, transmissibility law. And if you're coming for laws of moments, Varignon's theorem, this is very, very important in dynamics. So reciprocating forces, then balancing of rotating masses. So in that places, this particular Varignon's theorem is very important. Varignon's theorem shows that the law of moments. What is meant by moment? If one particular point, the force is acting, but you are measuring or you are taking the force with respect to a point. So moment is nothing but moment is unaltered. It is like what we can say that the force is given in the rotational form. So how you are using the spanner to remove the bolt. So that is that's the way this moment, what we can say, law of moments is very helpful. So for any system of forces acting in the space, the algebraic summation of all the moment of all the forces about a point is equal to the individual moment or resultant moment about the same point. So individual moment is equal to your resultant moment. That is the meaning for this. So moment means force into perpendicular distance. When the perpendicular distance is there, moment will be there. When the perpendicular distance is 0, the moment becomes 0. So these things are basic knowledge, and you need to apply in your dynamics and kinematics, everything. Already I said. Okay, so in this dynamics of machinery or dynamics, you'll read about balancing masses. Already you started or not? Third year people. Is it possible to be?
Somewhat rough only, ma'am.
Yes. So they started.
Yes, ma'am.
Yes. So in that place also you will apply mechanics only. F cos theta, F sin theta, turning moment diagrams, and how much force is acting in piston, how much force is acting in the flywheel, everything will come under this. So in these places, this Varignon's theorem plays vital role. So you can find out the resultant force, resultant position. So in that places, this will be very helpful. So now basic comes to the basic. Whatever may be the forces, and in whatever may be the body or object, either it is engine or machine or solid structure, trusses, beams, then columns. You'll read so many varieties of structures and numbers, everything. So whatever may be the thing, the basic involved, that is equation is resolving the forces in force system is sigma fx equal to 0, sigma fy equal to 0, and sigma m is equal to 0. So you will read or you will utilize this particular in n number of places. So this can have a little sigma fx and sigma fy is wherever you have cases, wherever you have metals and which places you are using the two-dimensional bodies. So you can say n number of applications. The same way, sigma fx, sigma fy and sigma m equal to 0. This is mainly used for three-dimensional. That is length, height and breadth. So here itself I have given you, just see that the forces acting in the ropes, wires, plates, etc. comes under two-dimensional. So I said them already. So these are the examples I have given. So forces acting in all three-dimensional bodies, beams, columns, structures, trusses, everything comes under this. So this is the next application. This is a very simple basic thing. So equilibrium. What is meant by equilibrium here? I forgot to say about this equilibrium. Equilibrium is nothing but when the body is in condition, means it does not take any unbalanced force. That means it is all the forces acting on the system becomes net force is equal to 0. That means forces are getting compensated. Suppose if I am sitting on the table, my weight acts on the table and the table gives some amount of reaction to the body to withstand in the same condition. So that is called equilibrium condition. Whether it is clear or not. Equilibrium means don't think that all the forces are acting on the system is 0. It is not correct. The net force acting on the system is 0 or acting on the system is null or very negotiable. Then only the body is in stable condition. So equilibrium ante what it means, the body is in stable condition. So stable means how can you say that if it is in moving condition, how can you say that like this? Suppose you are riding a bike, then how it will be stable? You can ask like this. There you will get more amount of forces. That force is also satisfied or it is equilibrant with the help of the mass of the body. So that is called dynamic equilibrium. Static equilibrium means only these two comes under the picture, and dynamic also will comes under that. Moment also comes into picture, and all the forces are acceleration, velocity, everything comes under picture. If it is in static, only static means forces alone will come. When it is in moving, F equal to ma, the Newton's second law also applied, and that forces also comes into picture, and that things also comes satisfied. So that is your major thing. So equilibrium, resolving forces in a force system or whatever may be. So if you want to keep your body in stable condition, this one is very important. Okay. So next one, I told you that already. So whatever may be the thing, the force system is very important. Force system is nothing but what are all the types of forces you may see in your regular day-to-day life. Because the forces are acting on a body. Force is not a single force. That means a single thing. It is a force means it is always exist in between two bodies. That one you should remember in your mind. Sometimes they may ask the basic question also. So what is meant by force? How it will be? How can you characterize the force? Force is nothing but it always exists in between two bodies. It is a relative motion, or you can say that it is always related with two bodies. It is not a single thing. It is not an individual. It is dependent. So with one body to another body only you can magnitude your force or you can evaluate your force. It is not a isolated one. So always the force system is very important. So in which way the force systems will exist. So you just see that collinear forces. Collinear forces means in a single line of action, the forces will continuously work. So the rope tug of war, simply they'll say that tug of war like that. That means in a single rope, all the forces acting in the same direction. So if it is in opposite direction means collinear, non-parallel. If it is in the same direction means collinear parallel, like that. Then coplanar force. Coplanar means in a single plane the forces will act. Coplanar like parallel force. Parallel force means it works in a single parallel condition. So I'll show some of the figures, then you can able to understand. So these are various types. You just keep it in your mind. Coplanar concurrent, coplanar non-concurrent. By name itself, you can able to identify that non-coplanar, non-coplanar concurrent, non-coplanar non-concurrent. So these are the sum of the forces. So collinear force system it is. And now you just see that coplanar parallel force system. Coplanar parallel force system, the railway bogies comes under this coplanar parallel force system, and this is one type of beam structure. So trusses, beams like this, what we can say that building structure has a beam like this. This is also one more force acting on a beam also comes under coplanar. The meaning is in a single plane all the forces are acting. And then coplanar non-parallel. Non-parallel we can say like this. This is one amount of force acting here. This is acting here down towards down. And this disk reactive forces acts up. So two forces up and two forces down. And coplanar concurrent system. So this is concurrent. Just see that in a single plane, so in a single point, all the giant wheel buckets acting towards this particular point. So coplanar concurrent system. And coplanar non-concurrent. Coplanar means that this ladder comes under coplanar and these forces are acting in a different points, non-concurrent. So it is not in a single point, it is acting in different points. Okay, then non-coplanar non-concurrent. We just see that. So non-coplanar means this is one plane. Here this is not a plane. This is not a single plane. Just see that this is one plane, this is another plane, this is another plane, and this is another plane. So in these four planes, four forces are acting. So non-coplanar, non-concurrent parallel system. So you can say that non-coplanar concurrent system. So the tripod of a camera comes under this non-coplanar non-concurrent. That means concurrent. So in this particular point, all the forces are acting together and the planes are getting different. You just see here. And now non-coplanar non-concurrent. One more example here. So previous one I have shown here, non-coplanar non-concurrent. One more example for this, the persons moving in a body, moving in a bus. So each and every person taking a support of different places. So this comes under non-concurrent. And this is also tripod, coplanar like parallel forces. So everything, the steering wheel comes under concurrent force system. You just see that. So you can easily apply your Lam's theorem here with the help of this. So transmissibility law here it is very well suitable. You can see that how it changes. So if you are applying transmissibility, this force comes in here from this like this, and this force will move like this, and this force will move like this. So now concurrent forces. And now you just see that. And this is coplanar non-concurrent forces. So you just see here in a single plane, 1, 2, 3, 4 forces connected here in a single point. So these are practical examples. And this is also one of the truss, pin post truss or pin post truss. So in this also the coplanar non-concurrent forces. So in different places, different points or different directions, all the forces are acting. So coplanar in a single plane, you just see that this is a two-dimensional structure. In this two-dimensional structure, everything is acting. Okay, non-coplanar, non-concurrent. The car vehicle or vehicle tires having loads on it, space, truss. So these are all some samples. And what are all the kinds of forces? So you'll get that nearly 5 different types of forces. Always, wherever you can go, you can take the forces in any one of these types. So that is tensile, compressive, shear, bending, torsion. So if you're taking tensile, pulling, compressive, push. Shear means one part of the body kept as it is, another part of the body moves. So the difference between these two and this one shear force is nothing but the tensile and compression applied through the axis of the body. The tensile and compressive applied through the axis of the body. Axis of the body means the center of the body, and shear is nothing but one side it is attached, another side. So that means the tangentially the force is applied. So what will happen? Partial deformation will take place in this particular one. Partial deformation. And bending force, it is especially in beams. So beams, while applying the forces, one side it takes the expansion, another side it takes the compression, both together. So tensile and compressive both together will take place in bending. And torsional means it is especially in circular objects, especially in shafts. So in shafts, what will happen? The force, whenever you are applying the force, the deformation takes place. So in these cases, the deformation takes place elongation or compression. But in this case, the deformation will take place in an angular manner. Angular means radiance. Radiance, you can say that twisted manner or in circular manner, radial. That is the main major difference. So in previous regular classes, I would explain this much of detail in detail because say that you know the difference in all these five forces. Force means it does not in the activity axis. It is applied one edge or adjacent to the body. One side is fixed, another side is movable. So one side it has its original dimension, another side it takes some amount of deformation. That is a shear force effect. Tension forces, pulling effect, compressive forces, pushing effect, bending forces, the combination of these two, and torsional force, twist force, or the elongation will take place in inclined form. So that is torsional force. Okay. So these are the various types of forces, whatever I explained there. So you just see that this is pulling force, tension force, and this is your tension force again, and this is a compressive force, and here compressive force, and this is also compressive force. Example for tension and compressive forces. Shear force, bending force, you just see that this is a bending force. I said that bending force means one side it takes the expansion, another side it takes the compression. So you just see here the bottom of the beam takes the expansion and here it takes the compression. So here also you just see that this particular part will get expansion. The whole person, the body of the person also will get expand and compressive. And this is called torsional. Torsional means always it takes the twisted angle, angular way. Deformation itself we will measure in theta or radians. That is called torsion. And this is called shear. Shear means one side it is fixed, another side is movable. Here it will take the deformation. That is shear. Okay, so these are the various types of formations you have. And resolving the forces, usually the resolving the forces, you have that using the, if you have one or two forces means you can apply for Lam's theorem or triangle law, polygon law, or parallelogram law, everything. But if the forces are more than two or more than three, if three forces acting means Lam's theorem you can apply. But if it is more than three, we could not apply any one of the law. At that time, this resolving the forces in concurrent system is very helpful. So this is very basic thing. So if you know only this alone, you can solve any forces, either it may be two or three. No need to remember this what we can say polygon law, parallelogram, nothing. So you can use any force system under this particular one. So resolving the forces in concurrent system, you just see that. So if the number of forces acting more than three, you must go by using this methodology. This one already I have explained, that resolving the forces in concurrent system. That means the force is acting in a particular point. You just see here 4 forces are acting here: F1, F2, F3, F4. So whatever may be the force, so this is usually you just see that in 2-dimensional means if the force is in exactly x direction or if the force is in exactly y direction, you can resolve it with the help of xy lines. But if the forces are in different angle, if the forces are in different angle, 1 second now. Yes, you just see. So now we can take this F3 or F1. So suppose for a single force, if it is not in x and y direction, you can resolve the forces in 2-dimensional. That means you are dividing into 2 parts. 2 parts means Fx and Fy. So suppose for example, if I am taking my force as R, single force as R. So theta x is here. Theta x is here means I need to resolve towards, I am rotating towards the x direction. I am rotating towards the y direction. So if I am taking like this, it's audible enough? Yes. Admit, is this particular person MR Reddy? I need to admit. Okay. So now just see here, suppose if I am taking this F1, so it is not in x direction, not in y direction. So at that time what will happen? This particular one you need to rotate to x direction as well as y direction. You are dividing into 2 parts of this total force. So if you are dividing into 2 parts, so this theta I am taking. So theta is here. So this Rx value, suppose if I am taking this R value, x component of this force. So the total resultant force is now divided into 2 forces. So like this, each and every force is divided into 2 components. So finally what you will get, R equal to root of fx square and fy square. So now you just see that, assume that this is a single force. Just see here, theta x is here. So now I know the value of R, but I don't know the value of Rx. So how can you solve this? So cos theta x equal to Rx by R. So simply Rx is nothing but R cos theta x. You can write like this. The same way Ry also you need to write it. So each and every time you just see here this way. So this is the summation of f1x, f2x, f3x, everything I have given. So now you just see that how you just solve. So R equal to root of sigma fx square plus sigma fy square. Summation of f1, f2, f3, f4 of x components and y components gives that the overall resultant of this particular. Why I need to find out the forces here like this? So the forces, why I need to find out? This is a basic thing, but suppose for example, a person is involved or tied up with 4 ropes. A person is tied up with 4 ropes. So which side the person can move? That one we can define or we can justify with the help of this particular force system. So wherever you have the net force acting on the system, that side the resultant will move. So that is the meaning. So a 4 persons pulling a person, pulling a single person. So which side he can move? So which force having that more amount of magnitude, that side the person will move. So that is the meaning for this. So F1, F2, F3, F4. Yes, someone is. So you can see that F1 cos theta x, F2, F1 cos theta x, and as well as F1 sin theta x. So this is very important to understand all the, or to resolve all the forces. F1 sin theta and F1 cos theta. So you can simply identify, or sometimes you will get the confusion with this. So for that, a simple clue I have given already. If theta is near to axis, cos. If theta is away from axis, sin. So that one you just keep it in your mind. So one thing that is more than sufficient to resolve all the forces. While explaining elaborately, that one you need to find. So why we need to find out these things? You just see that the unknown forces almost in the regular practical life, in which way you can use this methodology or this concepts means to find out unknown forces. So relevant to this one problem I have done, you can go through this. Time is up. I'll complete with this next one. So I'll brief my session. Okay. So before that, the free body diagram plays a major role. So free body diagram, how you have to draw this, in which way you can do this free body diagram, that's very important. So free body diagram is nothing but simply we are removing all the supports. It's an imaginary diagram actually. It's an imaginary diagram. So the meaning is, so you are not at all involved with the supports. You are relieving all the supports and what is the forces acting on it, on a particular body, and whatever may be the force acting in the body, when the supports are connected, the supports give some reaction. That reactive force is also given in this free body diagram. So that is called free body diagram. You just see that it is a diagram in which the body is isolated from all the parts and represented all the forces acting on it, including reactive force also. So while drawing the free body diagram, 3 things you should remember. You just see here, 3 things you should remember. 3 things. What are they? So self weight always acts downwards, irrespective of body position. That is a major thing. Then support reaction always acts normal to the surface of the body. Why I have given this as a second one? So yeah, all of you feel that this is normal only, no like that, but it's not clear. You should know the difference. You just see here. You see here, the body weight is acting here downward. The body weight is acting here downward. You should know the difference. How the weight is acting downwards or how the reaction is acting. So the body weight is always acting down. If the body is inclined, that time also the body weight is acting down. You should know the difference. Okay, so in previous days you studied, but you studied for the namesake or you studied for the exam sake. But it is not correct now. So when you are applying these principles, you should know in which way logically you need to think of. Now you somewhat you are in 3rd year, so now you can analyze things. Okay, just see here, the body weight is acting down, the reaction is upward in the flat system or flat support. The same thing, if it is inclined, you just see the difference between the upper diagram to lower diagram. The weight is always acting down, but the reaction is where you have the support. From that place, you will get your reaction. So the body reaction always from support you will get. That is the main important difference between these two. Are you understood? Are you understood what I'm saying? Yes, clearly. One reply me. Anyone? Yes. So the body weight is always acts downward at any inclined position, but the reaction where the support is getting contact, from that place only the reaction works. These two things you should keep it in your mind while doing the free body diagram. Third force is when you force, already I told you that it is the existence in between two bodies. Always the force is nothing but it is an existence in between the two forces. So in between the two bodies. Just see here. So this particular body is getting support with this, and the reaction is acting up. So here you just see that two cylinders, two cylinders are resting in a particular channel. So one cylinder is acting on, one cylinder force is acting on another cylinder force is acting here. So always this in between force is called tension force. The tension force comes under these two free body diagram motion, and that too acts in opposite direction. So simply the free body diagram is, this is very important. So in this resolution of forces, you have that if theta is near, cos theta is as, if theta is away, sin theta, cos theta. That is very important. Second one is, while drawing the free body diagram, self weight, applied loads. So what are all the things you need to add it? You need to move it. Self weight, applied loads, minus supports and connections, plus reactions from supports. These three things. So reaction from supports, applied loads, self weight they won't give in the body. They will give in the sentences. You need to add it. If it is a very small weight means they won't give. At that time you can avoid it. So supports you need to subtract it. So this is called free body diagram. Okay. So this one you should keep it in your mind. And now next one. So these are all simple free body diagrams for some of the things. You just see that how the free body diagram will be for this particular problem. So now you just see that frictionless surface or something. You just see that inclined surface. So what we can say, the mountain roads or hill roads also comes under this. So the ball is resting on a surface, and this is the pulp is resting on a wall, and spear in groove. So these are all your what we can say that shaft, belt drives, everything comes under this black on surface. So these are all some of the examples. And resolving the forces in concurrent force system. So these are all also how the resolution will take place in a simple concurrent force systems. These are all called concurrent force systems. So you just see that the example. So how the transmissibility work here. Just see here. I wish to explain the transmissibility. Transmissibility means you just see that this cylinder, first cylinder I am taking. So what are all the forces acting on this particular cylinder? So here only one force they have given, not at all force. Simply one cylinder is connected with the another cylinder. That's it. They did not mention any forces on this, but you will get the forces. How you will get? Here one support is acting, here another support is acting. So these two supports produces some reaction. That reaction is always towards the body, and the body weight always acting down. But this body is attached with another body, so this body force also acts towards this particular one. So how many forces? 1, 2, and this force is acting down, 3, and the weight of the force acts down always. So you just see now how the force is acting here. So this is the upper cylinder, and I'll go for the downward cylinder. You just see that. So body weight acting down, reaction acting up, and this one side reaction also acting up, and this tension force or collision force. You can say that collision force also. This force also acting this direction. So totally 1, 2, 3, 4. So which law it is applicable here? Transmissibility law. Transmissibility law is applicable here because the same line of action you can change your force like this and like this. Is it clear to you? So how the transmissibility law works here? Okay. So now if you are going here, the same problem continued here. So now come for this. This is still now we have seen the concurrent force system. So in a single point. So now if you are seeing that coplanar force system, coplanar means it's like a plane. So while plane is coming means automatically the moment will come into the picture because all the forces are acting in different points. So you need to take a resultant momentum to find out your resultant force. So in these places, whatever we have done, sigma x, sigma fx, sigma fy, everything comes into picture. Along with this, moment also comes into picture. So why we need to take the momentum? So because each and every force acting in a different place. So at that time you need to so each and every point different forces acting in a different planes. So at that time you need to use the momentum. So this is your moment system. Now come for friction. So any force that resists the motion. So friction you know that very well. So any force that resists the motion. So still 5 more minutes I'll take because I've started. So now you see that. So I'll explain this principles involved in this simple brief introduction I'll give. So any force involves this is the motion and contact with each other. This is the force that keeps object from sliding down in plane. So friction gives always positive as well as negative impact in so many places. Suppose if you are taking the footwears, the friction plays very important role to give gripness. And if you are taking the automobile parts, the friction plays that negative impact. And if you are taking the musical instruments, it gives the positive impact. So like this. So 1 second now. Yes. So this is one more thing. So the friction moves always in opposite direction. And now you just see that this one how it works. So this is where F equal to mu n r. F by n equal to mu. The coefficient of friction plays a major role. So the friction always divided into two categories: static friction as well as dynamic friction. And now you just see that next one. So you always this one you just keep it in your mind. Static friction always greater than your dynamic friction because friction is nothing but it's giving the reaction against the movement of the body. It's giving the reaction or resistance offered by the surface to the body to avoid motion. That is the main thing. So always dynamic friction or sliding friction is lesser than the static friction or static condition. So when the friction is taken into picture, when the friction is taken into picture, so you may get that these are all the forces. You just see them. One more forces applied. Two forces applied here. So if the motion is applied, then only the friction comes into picture. Or even though if the motion is not applied, if the body is in stable condition, that place also, if the surface is very rough, at that place the friction is given. So you just see that the motion, when the motion is applied and the friction is applied in opposite direction. So motion is applied means the applied force here we can take it, and the body weight acts down and the force, the normal force or reactive force acts upward. So now this is very important, the cone of friction. So when the force is applied in particular angle, the corresponding force of friction also applied in the same angle in opposite direction. So at that time, if the applied force takes place in the positive x direction, exactly the friction force takes place in the negative x direction. The same way, if the applied force takes in positive 45-degree angle, the frictional force will take place in the negative 45-degree angle. So it creates a cone. So that's why it's called that cone of friction. This normal reaction always constant. Normal reaction always constant. The body weight also always constant mass. The friction always works with respect to the motion of the body. Okay, so it creates a cone. So it's called cone of friction. And these are the various cases applied when the force or when the body moves in an inclined plane. These are the various forces applied and the friction, how the friction is created in the plane. So I have given 4 different conditions. So based on this problems. So this is your friction introduction. So now I'll show you some of the problems involved in this. One second. So only two problems I have taken. You just see that. So if you're coming for trusses and dynamics, balancing of rotating masses, in that places you will get major number of problems. So for that, for solving that problems also, we require this knowledge. Okay. So here basic questions, 2 questions I have taken for a sample. My screen is visible or not?
No, ma'am.
No. Okay. Okay. Yes, you just see here, these are the 2 questions I have taken. So just the force F is acting on a bent bar which is clamped at one end shown in figure. So the correct free body diagram is, so free body diagram they asked. So which one you will get here? Just see here, this is the fixed one. This is the fixed one, and here the angle is 60 degree. The force is acting here. What ma? Anyone? What happened?
आज
So which
रात
one you may
12
get?
बजे से संपूर्ण लॉकडाउन होने जा रहा है.
Who is this person? Admit చేసిన తప్పు అయిపోయింది అది. So now you just see that it's a fixed body. The correct free body diagram you just see here. So this is the point Rx, Ry, and you just see here 1, 2, 3, 4 forces. So the 60 degree will come here as it is. Free body diagram means you need to remove all the supports. So this support is removed. So here the answer is A. Just see here. So 2 forces, it is Rx, Ry. So 2 forces acts here because of hinged support, and one more moment also will work here, and 60 degree. This particular one. So this A is correct answer for this. Okay. So next one, just see here. Next question. So acceleration due to gravity 10 meter per second. The block of mass rests on an inclined plane and is attached by a string to the wall as shown in figure. The coefficient of friction between the plane and the block is 0.25. The string can withstand a maximum force of 20 Newton. The maximum value of the mass for which the string will not break the block will be in static equilibrium. Thus, how many kgs they asked? Take cos theta equal to 0.8 and sin theta equal to 0.6. So that means theta value they have given cos theta and sin theta. So with the help of that you need to find out the weight. So weight means mg. Yeah, W equal to mg. So with the help of that you need to find out. So this is one case of free body diagram that we have done. So with the help of this resolved free body diagram you can resolve this particular problem. Okay. So with this I'll close this session. Okay, thank you so much.